This is Usman with O-Level Mathematics. I am back today with my third video on the topic vectors of GCSE as well as IGCSE syllabus. Students, as I told you earlier, we have to attain 6 main objectives in this particular topic. Number 1, calculate the magnitude of the vector, represent the magnitude by directed segment. Number 3, we must know how to add and subtract 2 or more vectors. Number 4, multiply the vector by a scalar number. And number 5, we have to learn how to use the sum and difference of 2 vectors to express them in single vector. And number 6, use position vectors. Students, objective number 1, 2 and 3, we have already discussed them in another tutorial whose link I am going to leave in the description box. And today the topic for our discussion is going to be multiply the vector by a scalar. So let's dig deep into this topic straight away. To understand the multiplication of a vector by a scalar, let us consider a vector A like this. This vector A is moving 1, 2 and 3 units in the x direction, 1, 2 units in the y direction. What I want to do here is to define how the vector can be multiplied by a scalar. For that, let us consider the vector A twice, like this. Now what we get here is the twice as the vector A going in the same direction. So what we can do here is we can replace this vector A and A with the vector B, which is equals to twice the vector A. Similarly, we can also draw one more vector with these two vectors A, and one more vector A. We can draw it like this. Now these three vectors moving in the same direction are very much similar to 3 times the vector A, and for that we can draw it like this. This 3A vector, which is represented by C, is moving in the same direction as A, but it is having its length 3 times greater than the vector A. Let us now explore the column vectors of these vectors, how the multiplication of a scalar to a vector affect the column vector of the vector A. Just see what we were having over here, the vector A, which was equals to 3, 2. It is moving 3 units in the x direction, 2 units in the y direction. And the vector B is twice. The scalar number over here is 2 times of A. Now when you multiply this 2 with the vector A, this is just a scalar number. This scalar means it is just scaling it. It does not has the direction. But A, which is a vector, see, it is moving 3 units in x direction, 2 units in y direction. So it has the direction. Now when we are multiplying 2 with it, we are getting B equals to 2 will be multiplied with the x component and 2 also multiplied with the y component. So 2 into 3, we are going to get 6. 2 into 2, what we are going to get? We are going to get 4. Similarly, if you see the vector C over here, it is 3 times of the vector A. So 3 times of the vector A means 3 multiply with A, 3 into 3 you are going to get 9, and 3 into 2 you are going to get 6. The intuition that I want to make over here is this one. What it says, if B, any vector B, is equals to some scalar number k times A, means if vector A is multiplied with the scalar number k and we are getting the result another vector B, then we say that A and this vector B both are parallel, as you can see in the diagram. Vector A and vector B both are moving in the same direction. But what is changing over here? They are having the different magnitude. Both are having the bigger length. A is having the smaller length as compared to the vector B. But the direction, it does not affect it. It means that the scalar number when multiplied with the vector can only alter the magnitude, but it cannot change the direction. So let's move on to some examples how we can multiply a vector with a scalar number and then add it or subtract it to another vector. So consider the example number 1. What we are having over here, a vector A equals to 2 units in x direction minus 2 units in y direction, and the vector B is equals to 1 unit in x direction, 2 units in y direction. Now what we have to find over here, A plus 2 times of B. The vector A, it is the same, but you have to multiply B with 2. So it means you have to increase its magnitude twice. So how we are going to do it? See, vector A replaced by 2 minus 2 plus 2 is the scalar number being multiplied with the vector B, which is 1, 2. Now first, what is the first step? We have to apply the BODMAS. First multiply 2 with the B vector. So what are we going to get? 2 minus 2 will remain 2 minus 2. 2 into 1, I'm going to get 2. 2 into 4 will give you 4. Now, and apply the addition rule of the vectors. X component with the x component minus 2 y component with the y component, which is 4. So 2 plus 2, what we are going to get 4, and minus 2 plus 4, what we are going to get is 4, 2. Similarly, you can also do the subtraction of the two vectors when they are scaled up or down. A minus 2b. Now 2 minus 2, you are multiplying with minus 2 times 1 over 2. So what are you going to get? 2 minus 2 plus minus 2 this time and minus 4. You have to change the sign of both. Means now vector B has increased its magnitude but moving in the negative direction and the negative sense. Now if you add them, you are going to get 2 minus 2 is 0, minus 2 minus 4, you are going to get minus 6. Now let's see this change after this addition, what happened graphically to these vectors. So just let us first draw the vector A, which is 2 units in x direction minus 2 units in y direction. So 1, 2, 2 units x direction, 1, 2, minus 2 units in y direction. Now for addition, we have to bring the start of the vector B on the end of the vector A, which is 1 unit in x direction and 2 units in y direction. But since we have to double the vector B, so if I multiply this vector B with 2, I am going to get this vector 2, 4. By doubling B, you will get 2 units in x direction and 4 units in y direction. So let's bring vector 2b at the end of the vector A, which will look like this. 1, 2 units in x direction, 1, 2, 3, 4. 4 units in y direction. Now what will be the resultant of A plus 2b? It is going to be the resultant vector starting from the start of the first vector and ending at the end of the second vector, which is 2b. So this is going to be your resultant vector A plus 2b, and it is having its coordinates 1, 2, 3, 4 in x direction and 1, 2 in y direction, very much similar to this one. And same goes for the last one, A minus 2b. How it is moving? It is moving A 1, 2 units in x direction, 1, 2 in y direction, but in the negative sense. Now we have to bring twice of B, but this time since the sign is negative, so we have to draw the same vector in the opposite direction. So it is moving minus 2 units in x direction and minus 4 units in y direction. So here we have to move 2 units in x direction but in the negative sense. So 1, 2 and minus 4 units in y direction. So 1, 2, 3, 4. So our vector 2b in the negative sense would move over here. So what is the resultant? We'll start from the first vector A and will end at the second vector minus 2b. So this is going to be the resultant. Now if you see the vertices of your last resultant vector, what we are going to get, it is moving 0 unit in x direction but 1, 2, 3, 4, 5, 6 unit in the y direction but in the negative sense. So it is 0 minus 6 vector of this A minus 2b combination, or the resultant of A minus 2b. And this brings us to the end of today's tutorial. As always, thank you very much for watching Mathematics with Usman. See you in another tutorial. Till then, it's goodbye.